Hello students, welcome to Account-Wise Academy. This is Latha Venkateshwaran. In today's topic, let us learn about time value of money. Value of rupee received today differs from that of a rupee received in the future. In simple terms, we can say that a rupee today is worth more than a rupee in the future. Here today means present. Let us assume that we have got rupees 50,000 today in 2023. With this money, we can buy a fridge and a washing machine. Is it possible to buy the same products in 2033 with the same amount? Definitely no. So, the time value of money is a financial concept that recognizes the idea that a sum of money today that is present, that is rupees 50,000, is worth more than the same sum in the future. So, it is more than the same sum in the future. What are the reasons for it to lose value? The main reasons we can say as inflation and risk. Let us see why inflation. Inflation decreases the purchasing power over time, causing the sum of money today to have greater value than the same amount in the future. Next is risk. Let us assume that I am going to invest money in some company. What is the risk I am going to undergo to get the money back? We know investments can be a bit uncertain, like a gamble. There might be a chance that things may not go perfectly and I may not get all the money that I had hoped for. Uses of time value of money or TVM. Time value of money is widely used in finance for things like deciding how much to save for the future, evaluating investments, understanding the real cost of loans. Let us see one by one with an example. How much to save for the future? TVM is used to determine how much money individuals need to save today to reach a specific financial goal in the future, such as buying a house or funding education of your child. Let us take an example of buying a house in 2043 for rupees 15 lakhs. Sorry, 50 lakhs. 15 lakhs is too low. Even this is low in 2043. For our understanding purpose, let us take it as 50 lakhs. In 2023, how much you need to have today for that to fetch you 50 lakhs in the future? So, how much you need to save today to fetch you 50 lakh in the future? To save for the future. Evaluating investments. When evaluating potential investments, TVM helps in estimating the present value of expected future returns. You are expecting a future return of 1000 rupees per month from 2043 to 2063, that is for 20 years. Now you are in 2023 present. How much you need to have today so that it can fetch you future returns of 1000 rupees per month. So you need to find out the present value of expected future returns. That is for evaluating investments. Next, for understanding the real cost of loans. Okay, so it helps borrowers and lenders assess the present value of future loan payments, allowing for informed decisions about borrowing or lending money. Suppose I can pay rupees 15,000 per month for 20 years period of time. Okay, how much money am I eligible to get today? So that I can pay 15,000 per month. So present value of future loan payments. This is the future loan payments. For that I need to find out the present value. PV is present value. Okay. So TVM helps us compare value of money at different points in time. So what are the different points in time in our examples? It is 2043 here, and that is 20 years. Here also 20 years, and here also 20 years. So different points in time. Okay. Now let us see what exactly is time value of money. So it is used to find the present value of future value and to find the future value of the present value. What is this value? What is this future present? It might be confusing, but it's not, so it's very easy. Let me explain it with an example. First let us take to find the present value of future value. Okay, so let us assume that in 2028 we need 5 lakhs rupees. So 2028 is future value. 2028 is future, right? Yes, 2028 is future, so it becomes future value. Okay, so 2028 we need 5 lakhs. How much should I have to have today for this money to grow to 5 lakhs? So, you think of present value as the amount of money you would need right now. So, this is the amount of money which we need right now to make sure you have a certain amount in the future. The certain amount here is 5 lakhs. It is like asking, how much money do I need to have today so that with a little magic it turns into the exact amount I want in the future. So this money with little magic turns into the exact amount I want in the future. Next we shall see to find the future value of the present value. This is quite opposite of the previous one. So we'll for this also we'll take the same example amount, that is 5 lakhs. So let us say in 2023, that is present value, I have 5 lakhs. How much money will I have in the future with this amount, or how much money will this money grow to in the future, that is in 2028. Okay, so imagine you have some money today, that is rupees 5 lakhs I have today, and you are curious about how much it will grow in the future. Future value is like peeking into the future to see how your money will grow over time. You want to see the future and see how much my money is going to grow. It answers the question, if I have this much money now, how much will it turn into in the future, that is in 2028. Discounting or discount rate or discount factor. Think of the discount rate as the extra profit an investor wants to make when they put their money into a company. So discount rate represents a rate of return or the extra profit required by an investor to invest in a company. This extra profit or the rate of return takes into account two important things. They are the time value of money and the risk associated with the investment. Discounting is commonly used to evaluate the attractiveness of an investment by comparing the present value of expected future cash flows with the initial cost of investment. Okay, so let us take this with an example. Consider we have to invest in a project worth rupees 1 lakh. So this becomes our initial cost of the investment. So here it is the initial cost of the investment. and we expect future cash flows from this investment as for year 1, year 2, year 3 as 30,000, 40,000 and 50,000. When you sum it up, you get 1,20,000. So these are our returns, future returns. Okay, so on the face of it, it looks that the future returns are greater than 1 lakh. That is, so it is good to go ahead with the project. But is it the correct way to go? No, we know that money loses its value over a period of time. So for that, we have to take the present value of the expected future cash flows. Okay, here we have only cash flows, future cash flows, but we need present value of expected future cash flows. Okay, for that we need a discount rate. That discount rate, for our example, we'll take it as 10%. Now we will convert 30,000, which is future value, to the present value by applying the discount rate of 10%. Similarly, for 40,000 and 50,000, we will convert to the present value by applying a rate of 10%, and we'll get an amount of rupees X. If this rupees X is greater than 1 lakh, we can go ahead with the project, or else it's not a good idea to go ahead with the project. What is this discounting factor or discount rate or discounting? So this is like a magical number that represents how much the value of money decreases over time. Okay, using the interest rate, we discount the value. Now let us see what is interest. So interest is the cost of borrowing money, or it can be also called as fee for using money. Okay, so when you borrow money, you pay interest. What do you do when you borrow money? You pay interest. Similarly, when you save money in a bank, you earn interest. Okay, so interest is like a percentage. So it's like a percentage that decides how much interest you earn or pay. For example, let us assume that you are saving ₹1,000 or you are borrowing ₹1,000, and if the rate of interest is 5% for that, this is the interest rate, and ₹1,000 5% becomes ₹50. That becomes your interest amount. Similarly, if you take it at 10%, this 10% becomes our interest rate, and ₹100 becomes our interest amount. There are two main types of interest. They are simple interest and compound interest. Simple interest is like a straightforward fee on the original amount you borrow. So it's a straightforward fee. See, here ₹1,000, 5% straightforward, you're going to pay ₹50. Next year also you're going to pay only ₹50. So it's straightforward. Whereas compound interest is interest on the initial amount plus interest that adds up over time. Here, first year it will be ₹1,000, interest will be 50. Second year, this amount will become 1,050 and the interest will be 1,050 into 5%, some X. And third year, this 1,050 plus X will become your amount and into 5%, some Y. So it goes on like this, interest plus interest adds up. Understanding interest helps you plan for the future and decide if loans or investments are a good idea. It is a key part of the time value of money, showing that money's value changes over time. Let us now see how the two main types of interest, that is simple interest and compound interest, works. Simple interest is like a little fee or reward for borrowing or lending money. Okay, this is for like a little fee or reward we pay for borrowing or lending money. It's simple because it only looks at the original amount you borrowed or invested. Let us see how it works. Let us assume that we borrowed ₹10,000 from a bank and pay back at an interest of 5% per annum. Here, rupees 10,000 becomes our principal amount. Rate is 5%. Now, simple interest, how do we calculate? Formula is principal into rate into time. Sorry. So, for 1 year it will be 10,000. What is the rate? 5 by 100 into time is 1. It becomes 500, rupees 500. For 3 years, it is 10,000 into 5 by 100 into 3. So interest for 3 years will be 1,500. So every year it is only 500. Second year 500, third year also 500. And cumulatively we can say for 3 years it is rupees 1,500. So interest, simple interest is straightforward and the amount remains the same every year. Now let's see what is compound interest. Compound interest compute interest on both principal and interest. Let us take this same example, rupees 10,000 borrowed for 3 years at 5%. Compound interest compute interest on both principal and interest. That is what we saw. So, for first year, interest will be 10,000 into 5%, that is 500, and the amount will be 10,000 plus 500 for the next year, that is 10,500. Next year we have to take 10,500 into 5%, which comes to 525, and we will get 11,025 for the next year. How did we get 10,500 plus interest for the current year is 525? So next year the principal amount will be 11,025, and for that, on that 5% it will be 551, that is 11,576. 11,025 plus 551 amounts to 11,576. So total interest on compound interest for the 3 years is 500, 525, 551.25, which is 1,576.25. Whereas for simple interest it is only 1,500. For compound interest it is 1,576.25. Here, as the amount is only 10,000, you can see that the difference is only very less, 76 rupees. But when the amount is huge like 10 lakhs, 20 lakhs or 1 crore, the difference will also be huge. What is the formula for finding compound interest? It is P into 1 plus I the whole power n minus P. Here P is what? 10,000, and 1 plus I is 1 plus 0.05 to the whole power of 3, which is, this amounts to 1.157625. So into 10,000, the total amount comes to 11,576. From this, if you deduct the principal amount, what is the principal amount? 10,000. 10,000 rupees. You will get compound interest as 576 for third year. Sorry, the 1,576 for 3 years. Let us see how compound interest amount changes when it is charged annually, that is once a year, semi-annually, that is twice a year, quarterly, that is 4 times a year, and monthly, that is 12 times a year. So it is annual compounding, semi-annual compounding or half-yearly compounding, quarterly compounding or monthly compounding. We know the formula for compound interest is P into 1 plus R to the whole power of n minus P. So for our example, let us assume P as 100, R as 10%, and n number of years as 1. Okay, so it's straightforward for us for once a year. 100 into 1 plus 0.1 to the power of 1, that is 100 into 1.1 minus 100, which is 110 rupees is the interest when it is charged once a year. Let us see how the interest changes when it is charged twice a year. For this, we have to take a factor called T is equal to 2. Since it is charged 2 times a year, we take T as 2. What we have to do with T? What we have to do is, we have to divide R by T and multiply n by T. What is R here? R is 0.1, 10%. So T is 2. So R by T is 0.1 divided by 2 to the whole power. What is n here? N is 1 to the whole power 2 into 1. Okay. So minus 100. So 0.1 divided by 2 is 0.025. 1 plus 100 into to the power of 2 minus 100. 2 into 1 is 2. So 100 into 1.05 to the power of 2 is 1.1025 minus 100. Okay. So multiplied by 100, which is 110.25 minus 100. So our interest changes to 10.25 when it is charged twice a year. Let us see how our interest changes when it is charged quarterly, that is 4 times a year. So what is T now? Since it is charged 4 times a year, T is 4, right? So we know we have to divide R by T. So 0.1 divided by 4 and we have to multiply N divided by N into T. So what is N here? N is 1, T is 4. 4. So we have done that. So what is that? 1.1 divided by 4 is 0.025 plus 1, which comes to 1.05. 4 into 1 is 4 to the power of 4. So what is 1.025 to the power of 4? It is 1.1038 into 100. 100 into 1.038 is 110.38 minus 100. So our interest now is rupees 10.38. Now let us see how our interest changes when it is charged 12 times a year or when it is compounded monthly. So what is our T now? Since it is charged 12 times a year, T is what? Yes, T is 12. So R by T is, R we know 0.1, T we know 12, 0.1 by 12 to the power of N into T. N we know as 1 and T is, N is 1 and T is 12, correct. So 0.1 divided by 12 is 0.0083. So substitute here, it becomes 1 plus 0.0083 is 1.00833 to the power of 12. What is 1.00833 to the power of 12? Which is 1.1047. I have taken only 4 decimals here, okay. So into 100 is 110.47 minus 100, it is 10.47. You can see however interest changes. For 1 year 10 rupees, twice a year it is 10.25, 4 times a year it is 10.38 and 12 times a year it is, that is monthly compounding, it is 10.47. Let us see how time value of money and compound interest work together or how they coexist together. We can say that compound interest is like magic for your money. Okay, so it is a fundamental concept of the component of the time value of money. So compound interest shows how your money can grow over time and helps you figure out how much it's worth at different times, at different points of time. So in the previous slide we saw how our compound interest worked when it was charged for 1 year, when it was charged for half a year, when it was charged quarterly, and when it was charged monthly. Okay, similarly, we also saw how compound interest works when it is charged for 1 year, 2 years, 3 years, etc. Okay, so when you are thinking about the present or the future value of money, compound interest is a secret ingredient that helps you understand how money's value changes over time or how the time value of money works. Do like our video and share it with your friends if you find it helpful. Subscribe to our channel, which will encourage us to make more videos like this one. If you would like to inquire about the accountancy classes which I take or to get more worksheets for problems with solutions, contact us at acct.wiseacademy@gmail.com. Thank you for watching.